Let's now look at the major components used in our AEM robot and understand their role in the project. First, the Arduino Uno acts as the brain of our robot. It processes sensor data, receives wireless commands, and controls all robot operations. Next, the L298N motor driver controls the speed and direction of the robot's motors based on commands received from the Arduino. The SG90 servo motor rotates the ultrasonic sensor left and right, allowing the robot to scan its surroundings for obstacles. The HC-SR04 ultrasonic sensor measures the distance to nearby objects and helps the robot avoid collisions during autonomous navigation. The LCD display shows the current operating mode, commands, and sensor information in real time. The HC05 Bluetooth module enables wireless control of the robot using a smartphone in Bluetooth mode. The NRF 24L01 wireless module receives gesture commands from the handheld transmitter and enables wireless communication between the remote and the robot. The LM2596 buck converter provides a stable 5-volt supply to the Arduino and other electronic components from the battery pack. Finally, the BO motors with wheels drive the robot forward, backward, left, and right, providing the movement required for navigation. Together, these components enable our AEM robot to receive commands, detect obstacles, communicate wirelessly, and navigate intelligently in different operating modes. Now let's see the working of our AEM robot. The robot operates in 3 modes: Bluetooth control, NRF, gesture control, and autonomous obstacle avoidance. In Bluetooth mode, commands from a smartphone control the robot wirelessly through the HC05 module. In NRF mode, hand gestures are transmitted using the NRF 24L01 modules, allowing gesture-based control. In autonomous mode, the ultrasonic sensor and servo continuously scan for obstacles, enabling the robot to navigate safely on its own. These 3 modes make our robot smart, flexible, and easy to control. Now let's start the car. As you can see, the robot has powered on successfully. Let's begin with the first mode, which is the default mode of our robot, Bluetooth mode. On the LCD display, we can see that the current mode is Bluetooth. We have also added a collision avoidance feature. The ultrasonic sensor detects obstacles in front, while the infrared sensor detects obstacles behind. If an obstacle is detected, the robot automatically avoids the collision and pauses Bluetooth or NRF commands for 3 seconds before resuming operation. Now, we have connected the HC05 Bluetooth module to our laptop. Let's try the first control mode, which is Vision Gesture mode. In this mode, our Python program opens the laptop's camera using OpenCV, while MediaPipe detects and tracks the tip of our index finger in real time. The center box represents the stop position. When the finger moves upward, the robot moves forward. Moving the finger downward makes it move backward, while moving left or right turns the robot in the corresponding direction. The corresponding movement commands are sent from the laptop to the HC05 Bluetooth module using Bluetooth communication. The Arduino Uno receives these commands, processes them, and sends the appropriate control signals to the L298N motor driver. The motor driver then drives the motors, allowing the robot to move forward, backward, left, or right according to the detected hand gesture. Now let's move to the second Bluetooth control mode, which is the WASD keyboard control mode. In this mode, the laptop keyboard is used to control the robot. Pressing W moves the robot forward, S moves it backward, A turns it left, and D turns it right. These keyboard commands are sent wirelessly over Bluetooth to the HC05 module. The Arduino Uno receives the commands and instructs the L298N motor driver to move the robot in the corresponding direction. Now let's look at the next Bluetooth control mode, which is canvas routing. In this mode, a canvas appears on the laptop where we can draw any path or shape. Once we click Run Path, the robot follows the same path automatically. We can also clear the canvas to draw a new path, and an emergency stop button is provided to stop the robot instantly whenever required. Now let's switch to the NRF Gesture Control mode. By pressing the second button, the robot enters NRF mode. The MPU6050 detects hand movements, and the NRF 24L01 wirelessly sends the corresponding commands to the robot. Let's see it in action. In NRF Gesture Control mode, we use a handheld transmitter equipped with an MPU6050 sensor and an NRF24L01 wireless module. Another NRF24L01 module is mounted on the robot. The MPU6050 continuously detects the hand's roll, pitch, and yaw movements, and based on these gestures, commands such as forward, backward, left, right, and stop are generated. These commands are transmitted wirelessly through the NRF modules to the robot, which then moves accordingly. Alongside this, a real-time simulation runs on the laptop, allowing us to visualize both the hand movements and the robot's movements simultaneously. Now let's move to the third mode, autonomous obstacle avoidance. Here, the ultrasonic sensor detects obstacles in front, and the servo scans the surroundings by rotating left and right. The Arduino compares the available paths and automatically guides the robot through the obstacle-free direction. This concludes the demonstration of our AEM robot. Thank you for your time and attention. We hope you enjoyed the presentation.